Okay, so I'm going to translate it right about here. And the reason I chose that spot is because it looks like if I keep it right there, then I could reflect it right over the x-axis. Because if you look at point A and A prime, one is 2 up and one is 2 down. So I could say that I translated. Now we have to figure out how far we went over. It looks like from point B to B prime, I went over 1, 2, 3, 4, 5, 6, and down 3. So I translated over 6 down 3, and my second step would be to reflect over the x-axis. That's one way you could do it. You could also have reflected over a different line depending on where you translated it. I chose that spot so I could use the axis. You could go right and match up A with A prime and reflect it over a different line if you wanted to. So there's multiple ways to do it. As long as they work, you're fine. This problem wants us to map AEB, which I outlined in pink, onto triangle CED. Now you see that I have a purple dot on the middle point there, which is point E. It looks like an F, but it's really an E. What I'm going to do is rotate the pink one about point E. We can't say 180 degrees because we don't have a grid, but we can say such that A maps onto C or such that B maps onto D. So the entire phrase that you need to write down is you're going to rotate triangle AEB about E such that A maps onto C or B maps onto D. Similar problem, but I want you to notice that G maps onto D. They correspond with each other. So if you look at G and D, that must be a rotation, not a reflection. So we know we're rotating. Very similar to the last problem, we are going to take GEH and rotate it about E such that G maps onto D or such that H maps onto F. So pause the video, rewind what I just said, and write that down. This is my favorite one because it has a little twist. There's a point that you have to rotate around that you don't even see, that isn't labeled. So we are going to map TUW onto VWU, which basically means the purple one onto the upper right half there. So the only way to do this is to rotate it like this. But what point did we actually rotate it around? If you remember this from class several weeks ago, that's the point we rotated around. So how do you explain that point? You rotate triangle TUW about the midpoint of WU such that T maps on to V. Okay, this problem is asking you to reflect that triangle over the line y equals -2. Now remember, y equals -2 looks like the x-axis, but it's actually horizontal because it cuts through the y-axis at -2. So you count from A down to the line, 5 and 5 more. There's your A prime. There's your C prime. And your B prime would be just off the page a little bit. And I have labeled it A prime, B prime, and C prime. That's what it's going to want if it says to label it. And then it says explain why it's congruent to its pre-image. Because a reflection is a rigid motion, and rigid motions preserve angle measure and distance. So you should write that down. I didn't write it because I want you to watch the video and write it, but it is congruent because it's a rigid motion and it preserves distance. This is normally done with patty paper or tracing paper, but it asks you to take quadrilateral CDGH and map it onto RLTY. If you put a piece of patty paper over this, marked the X and Y axis, and then rotated it so that the X and Y axis are still lined up, you'll see it maps right onto it. So this would have been a rotation about the origin of 180 degrees, which was 2 clicks. Okay, this one, unlike the last one, can't be done in one step, but there's really a whole bunch of things you could do with this one. I always suggest when you think there's more than one step to translate first. Get the two shapes close together, and then you can see whether it's a rotation or reflection or whatever you need to do next. So I was thinking about translating it something like that. And the reason I picked that, actually it was a little bit over from there.